Okay, let's do problem 23 on page 220 in chapter 8. And here's the problem. Okay, let's zoom in on it. All right. It says a person exerts a 55 Newton force on the end of a door 74 centimeters wide. What is the magnitude of the torque if the force is exerted A, perpendicular to the door, and B, at a 45 degree angle to the face of the door? And I've already kind of set it up right here. Like here's, and I always try to draw a picture of the problem. Oh, yeah, thank you. Oh, it's one of those days. All right. So here's kind of the door. We're kind of looking down on the door from the top, if you could cut away the house or whatever. And here's the hinge. And so this door is going to open like this. So you apply a force on the very end of the door, a 55 Newton force, and it's 74 centimeters wide. And I want to know what is the torque if my force is perpendicular like this, or what is the torque if the angle's 45 degrees, like in part B. Okay, so that's what we're trying to do. This becomes, by the way, the power of given, find, and solve. If you can draw a picture of the problem and visualize it, it's really an easy problem to do. So let's do part A, torque. Well, a torque from a force is equal to the lever arm times the force times the sine of the angle between. And I really kind of, I kind of use that word lever arm incorrectly there. The lever arm is r sine theta. It's the perpendicular distance, the shortest distance from the axis of rotation to the application of the force. And, but anyway, R is from the axis of rotation to the application of the force. So in part A, well, if I look at it, R, here's the axis of rotation. The force is 74 centimeters away. I'm going to do it in meters, 0.74 meters. Now, some of you left your answer in centimeters, and if the decimal was in the right place, you got 100% on it. So, but if you look in the back of the book, they leave the answer in meter newtons. And then the force is 55 newtons. Now, what is the angle between R? Well, I'm going to look at this. Here's R, and I'm going to extend R out like that, and here's the angle, and it's 90 degrees. And so that gives me a torque when you multiply 0.74 times 55. Well, the sine of 90 degrees is 1. So that's good. You get, and round it off to two significant figures, you get 41 meters times newtons. And you could list it as meters times newtons the way you did. Just put a little dot in between, because that tells the reader it's not millinewtons, because some people think it's millinewtons, and it's not. It's meters times newtons. You can put Newton meters as well. Now for part B, well, you have the same basic equation, but you have R, you have F, but now if I extend R out like this makes a 45 degree angle, like that. So it's the sine of 45 degrees. And so when you multiply that all out, you get a torque of something that rounds off to 29 meters times newtons. I think it was 2,900 meter newtons if you did it in centimeter newtons or whatever. Please always box your answers. And, oh, I'm off screen. That's just great. All right. So here's the whole problem. It's a pretty easy problem if you knew. The hardest part of this problem was setting it up and understanding what they were talking about. Okay? Any questions? Okay. That is
all.
All. That's all.